Welcome to Rges, Algebra 2. This is Lesson 23B, and we're discussing sections 7.3 and 7.4. I'm going to do a quick review on 7.1. I'm going to talk about 7.4, which has to do with finding square roots. And then I'm going to come back and do the hardest section, which is 7.3, but we also discussed it once in class. Now, in 7.1, we're talking about exponents. Now, let me review. Whenever we're thinking about dealing with exponents and operations with exponents, we always think that our exponent operation is going to be one level down from our variable operation. So what do I mean by that? Let's say if I have x to the third times x to the seventh. Okay. My variable operation is multiply. What am I doing with my x's? I'm multiplying. One level operation down would be add. Okay. So I'm going to add exponents. Now, it's easy to think about that visually. If I'm multiplying x cubed, that would be multiplying 3 x's together. And if I'm multiplying it by x to the 7th, that would be my multiplying by 7 more x's. 4, 5, 6, 7. How many x's do I have in all? I have 10 x's. So I've added. So this would be x to the 10th. I always think about this visually if I get stuck for any reason. On the other hand, if I had, and this is where you're getting a little tripped up, if I have x to the third to the 7th, my operation on my variable is power. I'm raising it to a power. I'm using the exponent. Okay, raising it to a power is a better way to think of the operation. And one level down, I'm going to multiply variables. Multiply my exponents. Okay. The power, the x, the variable, is being raised to a power, so I'm multiplying my exponents. Now, visually, I think of that as a group of 3 x's, 7 of those. 3 more, etc. And I think you can visualize how many x's you'll have in all. You're going to have 21. You're going to have 7 groups of 3. So that would be x to the 21. Now that's what I was testing in part of the quiz. And some of you remembered how to do that and some of you did not. So I'm going to go over number 5, 6, and 7 in the quiz. X squared y z cubed, all raised to the third power. That means I raised my x to the third power by multiplying exponents. 2 times 3 is 6. I may raise my y to the third power, and I raise my z to the third power by multiplying exponents. 3 times 3 is 9. And that should be your answer. Number 6, negative 6, a squared x cubed. I'm raising the entire thing squared, a negative sign. Think of a negative sign as its own deal. You want to deal with that first. A negative times a negative is what? Positive. Right? Remember, even numbers of negatives is positive. So this will be a positive number, not a negative. 6 squared is 6 times 6. That would be 36. Multiplying exponents, a to the 4th, x to the 6th. Number 7. Got it in the numerator and the denominator. I just have to deal with everything. I have to deal with the sign. I have to deal with the number in the numerator, the variable in the numerator, the number in the denominator, and the variable in the denominator. Just slow and steady is all you need. Okay. I have an even power. A negative to an even power will be positive. 2 to the 4th is 2 times 2 times 2 times 2. That would be the same as 4 times 4, or 16. C to the 4th. In my denominator, 3 to the 4th would be 3 times 3 times 3 times 3. That would be 81. Multiplying my exponents, d to the 8th. If I could reduce at this point, I would need to, but in this case, I cannot. Okay, now that was a review of 7.1. Let's go on then to 7.4, which is doing the opposite. It's finding the roots. We need to worry about numbers, variables. Okay. So here we go. We're going to have 7.4. First thing I want to talk about is signs. If I have a square root of a positive number, that's a good thing, because I would look for something times something, and whether the two numbers are negative or the two numbers are positive, the answer, which would be what's under the radical sign, would be positive. But if I have a square root of a negative number, that is not a real number. That's going to be called an imaginary number, and we'll deal with those later. Because I can't think of any number that you know about that you can multiply together to get a negative, just by itself one time to get a negative. Okay, so that's an imaginary number that you'll deal with later. Okay, so whenever my radical, whether it be, that's a square root, if it were a fourth root, it still has to only be positive. It cannot be negative for any even root, okay? Again, that would throw you into the imaginary number world. But what about odd numbers? Can I think of a cubed root, let's say? Okay. A cubed root of negative 27. Can you think of a number that I can multiply together 3 times? That would be a cubed root. In order to get a negative, it would have to be a negative number. What if I multiplied negative 3? Negative 3 times a negative times a negative times a negative is going to be a negative. And 3 times 3 is 9 times 3 is 27. So the cubed root of negative 27 is negative 3. The cubed root of positive 27 is going to be positive 3. And this will be true, so you can always have an odd root, meaning an odd number here in the index. Okay. You could always have an odd root of a negative number, but you cannot have an even root of a negative number without having an imaginary number. Now go ahead and read his explanation of that if you want to on page 169 to reinforce what we're talking about. Now basically when we're going to go ahead and talk about how do I do radicals when I only have variables. Very, very easy, by the way. Okay. If I have a to the 4th, b squared, c to the 6th. If I have no index here, it's going to be a 2, assumed to be a 2, a square root, and you're going to just divide. Divide by 2, every exponent. So I would end up with a squared b c cubed, just like that. If you have another one here, what if I had the 4th root of x to the 8th, y to the 4th, z to the 8th? I'm simply going to divide by 4, every exponent. Okay. So I'd have x to the 8th divided by 4 is 2, y to the 1st, or y, and z squared. I'm looking for anything complicated here. I've already talked to you about signs. Let me take a look. If you have a negative before the radical, that will mean a negative before the answer. Okay, so it should be pretty clear. Let's see. I'm thinking very clear up to number 12. Let's look at number 12 together. Okay, if I did not have the 243 and I only had the y to the 20th, I would have a negative And I would say, and I would divide 20 divided by 5, and that would be y to the 4th. But how do I deal with this 243? Well, I think the easiest way to deal with this is going to be to prime factor it. You'll have your clearest understanding of your numbers that way. So 243, if I divided that by 3, 3 goes into 24 8 times, then 3 goes into 3 1 times. This would be 9 and 9. This would be 3 and 3, 3 and 3. And you find out that 243 is 3 to the 5th power. That's good, because now I'll treat it just as I did the exponents on the variables. I took y to the 20th. I said 20 divided by 5 is 4. And now let's put that negative out further. And now for my number, I've got 3 to the 5th. 5 divided by 5 is 1, and this would be 3. Okay, see how that works? Let's go ahead and give you a couple more like that. Okay, my sign will have to be negative, and that only works with odd roots, but I have an odd index there, the 5, taking it to the 5th root. Okay, you can do this in primes, but first better to start with the division. If it divides evenly, I'd start there. 32 does go into 1024, and you're left with 32 in the denominator. Now convert that 32 to prime factoring, and it just now happens to be 2 to the 5th power, a to the 5th power. Okay. I've done the division, so I'll have x to the 5th of y to the 10th. So do that division ahead of time. Now you'll get negative, you're dividing everything by 5. This will be 2a over xy squared. Okay, I think that you should be able to decipher these yourself, and if not, come to class with and we'll discuss any problems you have. Now, let me go back to 7.3, which is related to 7.2. So I'll have a quick review of 7.2 as we did on the board. I showed you all of this idea in class, but I want you to have it on a tape where you can watch it more than once, because this is more challenging. Okay, in 7.2, you learn to take any binomial and raise it to a larger power. And you're going to have the number of the power you raise it to. For instance, this is x minus y to the 7th. I'll have 8 terms in my polynomial. And we learned how to get the x's, the y's, and most importantly and most difficultly, but not too hard, the numerical coefficient. Now, what if I have large ones like this and I don't want to calculate the entire thing because all I'm interested in is a certain term? For instance, in this one, I might be interested in the first, second, third, fourth, fifth, sixth term. Okay. I only want the 6th term, so I don't want to have to calculate it all out. What would I do? Well, you begin with your original equation and the power you're raising it to. And I care about the power, the exponent, that's the 7, and I care about the term I'm interested in this case, the 6th term, and I want to take that minus 1. Minus 1. So I'm interested in the number 5. I'm going to use the number 5 and the number 7 to get my answer. First, I'm going to take the y's. The y's are going to be this number, the term number, I'll call that, okay, which was really the term minus 1. Okay. The x's will be whatever exponent that will add up with that 5 to give me the exponent I began with. So that will be 2. And those will always add up in whatever term you have. And then the numerical is going to be dealing with the factorial. So I'm going to take 7 factorial going down and 7 factorial going up, but I don't want the entire thing. I only want 5 terms. So if I went all the way down, I'd have 7 terms, but I really want 7 times 6 times 5 times 4 times 3, and I'm leaving off the last 2 terms. Here I'm going to go 1 times 2 times 3 times 4 times 5, and I'm leaving off the last 2 terms. I'm going to cancel. 5's cancel, 4's cancel, 3's cancel, 2 goes into 6 3 times, and I'm going to get 21. Now, so where'd my start of my answer go is here. I'll put a 21, and my question is, will it be positive or negative? If my term is even and I have a negative here, it will be negative. So this should be the 6th term right there. Let's go back and check it. Yes. Okay, let's do that a couple more times for practice. And I did do it in class with you, so this should be a little bit easier. By the way, let's look at the, oh no, never mind. Let me start on a new page. I'm going to do number 6. Yeah, why not? Let's start with something a little easier maybe. Let's do number 7 actually. I think that's easier. The 18th term. Let's adjust my 1 minus 2x to the 20th. It is even, so it will be a negative when I'm done. This is a really long number. All right. I'm going to be interested in the 20, and I'm going to be interested in the number 17. I'm going to take this value, and I'm going to raise it to the 17th power. I'm going to take this value, and I'm going to raise it to the 3rd power, because 3 plus 17 equals 20. It will be negative when I'm done, and my factorial will be I will have 20 factorial going down and 20 factorial going up, and I want 17 terms. So if I think if I went 20 all the way to 1, that would be 20 terms. So I'm going to go 20 all the way down to, let's see, I need how many? 17 terms. So I will leave off the 1, the 2, and the 3. So I'll do it that way. I'm going to show you a little bit of a shortcut here. If you can follow it, fine. Otherwise, just write down 20 times 19 times 18 times 17 all the way down till you have 17 terms. Here, I only want 17 terms. I'm going up. Okay, so if you think of canceling here, I'm going to cancel all the way through 4. Okay, and so I'll be left with 20 times 19 times 18, and I'm canceling up through 17. So I'll just have those, and 1 times 2 times 3. So if you can see that, that would be a big help to you. Okay. Then, let's see, 3 goes into 18 6 times, 2 goes into 20 10 times, and I'm going to multiply that out. Okay, so I like to kind of break these, like I've got 2 to the 17th. I know what 2 to the 4th is. It'd be 4 times 4 is 16. And remembering that this is multiplying, if I said 2 to the 4th raised to the 4th power, that would be 16 of those, and multiply 1 more 2, and that would be 17. And that way I just punch in the calculator, 16 times 16 times 16 times 16. And then times 2, and then times 1140. And I get 149,422,080. Okay, x to the 17th, and I've got a negative number. So I think if you can do that, you probably can do all of them. And we're running out of time, so I'd say bring any of your other questions to class.